Charles, take it away.
Great. Thank you very much for that great intro, Chris. And yeah, happy to be here. As Chris mentioned, Charles Eckel. And in my role as a developer advocate, I get to work with a lot of developers. I'm very passionate about open source and also internet standards. And so the talk I want to give today is on applying those to the field of network programmability, something which can be a bit daunting to many engineers who kind of want to overcome that hurdle of getting started with programming, and hopefully show you how open source and standards make network programmability something you can tackle and actually quite easy. So, interesting study here. One of the things that came out of it was that human error is the #1 cause of network outage. And that's human error in multiple different forms. I don't think this really comes as a surprise to many people. Making mistakes is, to err is human. Just because, as human beings, when we do a task repetitively, sure, we perhaps get better at it, but we don't get perfect at it, and we certainly don't necessarily enjoy the repetition either. It becomes quite tedious. And we know that computers are actually much more predictable. They're great at doing tasks over and over again and getting it exactly right. So there's certainly room for improvement here in this area. Now, so as easy as flipping a switch. That's what I'd like to, hopefully, at the end of this talk, end of this 30 minutes, you agree with me that on my belief that network programmability and using network APIs can be as easy as flipping a switch. Electricity is a pretty complicated topic. How many of you are electrical engineers, or at least taken some electrical engineering classes? Yeah, there's a lot going on in the study of electricity and learning how to, all the peculiarities of it. But we all know how to do this. We all know how to flip a light switch and be masters of electricity, right? So very much the same, I think, with the APIs that are provided by the network today. As a network engineer, picking up the development skills that you need to automate your network is just as easy, hopefully as easy as flipping a switch. So just going to start from the ground up. First of all, what is an API? I've already mentioned it a few times. Application programming interface. Really just a way for two applications to talk to each other. And what APIs let you do is extend the functionality of something, or to interact with it, or to automate a task. You can build applications using APIs. You can extend the feature set of a product using APIs. We've all worked with many different APIs. One of the APIs is typing a URL into a browser and having it give you a web page back. When you do that, you're actually interacting with an API. And of course, the subject of the talk, you can use APIs to program networks too. So I want to focus on a particular class of API or type of API called a REST API. REST stands for Representational State Transfer. It's an API style, and really what it means is that a given API adheres to the principles of a REST API. I'm not going to go into the details of what those are, but it's basically some pretty well-specified principles around a client-server exchange where there's some very well-defined state that exists on a server, and then the client has well-defined APIs or mechanisms through which to interact with that state. It scales very well due to the nature of the way it's defined. One of the really nice principles is the server doesn't need to keep any state about the clients that are connecting to it. So that gives you some really nice scalability. And that's why you've seen web applications and web services scale so nicely and take off as much as they have. The basic flow of a REST API, and sorry this may be a little hard to read, but basically when the user of the API, the client, will send a request. In this case, it's an HTTP GET request to a server, which in this case is represented by Debbie, our friendly bot over there. Now, when Debbie gets this, does some processing on it, And that processing is not part of the contract. The client, the person over here on the left, doesn't need to worry about what that is. But at some point, a response will come back. And that is well-defined. Given a certain request, what should that response be? What is the format of that response? In this case, it's a 200 OK coming back with the information that was requested. And looking at the screen, it looks like the user was requesting a web page in this case. So let's look at a REST request in a little bit more detail. The way you build up a REST request and specify which resource you're looking for is by constructing what's known as the URI. And what I'm showing here are the components that always exist with a URI. First of all, the protocol. REST APIs can use different protocols, but typically different transport protocols, but typically they use HTTP, HTTPS, and that's what I'll be focusing on in this talk. The second part is the server or host that is hosting the API, right? The API server. In this case, I'm going to use something that we're hopefully all familiar with, a deck of cards. And there's this API hosted at deckofcardsapi.com. And this is a publicly available server if you want to try this out yourself. The resource I'm going to request in this case, I want to interact with the API, and I want to ask for a deck, and specifically a new deck of cards. So the request URI is built up with those components that specify the request I'm trying to make. Now, the other important part, in addition to the request URI, is the HTTP verb. And these HTTP verbs map to what's known as the CRUD operations, to create, read, update, and delete a resource. And they're mapped to the HTTP verbs post, get, put, patch, and delete, as you see there. Post to create something new, get to read something, put and patch to update something, and then delete to delete something. The other important thing to know is the status code. In our example, we made a GET request and we got back a 200. 200 class responses are typically successful responses, meaning that your request was understood and there's some information that will be coming back to you. 400 class responses generally mean there's something wrong with your request. Perhaps it's malformed. Perhaps you needed to provide credentials and you didn't. And then a 500 class typically means the server had an issue with your request. So there may not, unfortunately, be anything you can do. There's a problem on the server side. So you always have to look at the response code coming back, because that indicates if you're going to be getting back the information you requested or if maybe there's an issue. Okay, fortunately, there are some really nice tools for working with REST-based APIs, and I want to talk about a few of those here. One, as I mentioned earlier, just making a request in your browser. You're actually interacting with the REST API right there. Postman, how many of you have heard of Postman or ever used Postman? It's a great tool for building up sets of REST requests and storing them and then using them. And then I'm going to also, because it's about network programmability, I'm also going to look at Python, which is a language, a programming language, and specifically the request library of Python, which is really handy for interacting with REST APIs. Okay, so the first thing, just using the web browser. And this is the example I had before of the Deck of Cards API, the exact same URL that we built out before. If I just put that in my browser and send it, I actually get back JSON. JSON stands for JavaScript Object Notation. It's just a format, a structure for encapsulating data. And you can see the browser parses that response and shows me the information that came back. My request was successful. I got back a new deck. It's not shuffled. It has 52 cards, and I have an ID, a unique ID. So now I can do additional operations on that deck, like shuffle it, pull a card off of it. So I'm not going to go through all the examples of what you can do, but you could see where you could very easily start to interact with this Deck of Cards API just using your web browser. And like I said, this is publicly available. You could type the same request yourself, and you should get a similar response. So now what I'm showing, and hopefully you can see this, but the slides will be available if it's too small, making the exact same request in Postman. You can see I'm doing a GET request I put in the exact same URL, deck of cards, api.com/deck/new, and when I hit send, I get back a very similar response. And with Postman, the nice thing is you can save these requests and responses, and you can build up what's called collections of them and reuse them for later. But another really handy thing is if I click on code here on the right-hand side, it pops up a window where Postman gives me the option to see the code that would correspond to the request I just made. So you can see all these different languages. I mentioned Python before, but I could do it in Go or shell script, PHP, whatever your favorite one is, JavaScript, curl. I choose the request library because there's actually different libraries I could use. And I can see exactly what the code is that I would have needed to written in Python to make that exact same REST request. I can copy that code, and I can paste it into a file here called deck of cards API .py, which is the Python suffix. And you can see that's the exact same code. I just copied and pasted it here. Now I can run it from the command line by calling Python and my file name. And again, I get very similar output, very similar response. So you can see how without really even knowing any programming, I could use a browser, I could use Postman to create these requests, and I can generate the Python code. Actually, Postman generates it for me. And all I need to do is copy and paste it into a file. And then I can go and update these, modify them, reuse them as I want. But it really starts, hopefully, to show that network programming or programming to use this deck of cards API is not that complex. Okay, now the topic is network programmability, so we should probably talk about that a bit. So in addition to the tools that I just showed, like the web browser and Postman, there's a couple other things that make working with network APIs really user-friendly. And one thing is Yang. And what Yang is a data modeling language for describing network configuration and operational state. The really nice thing about this is rather than every vendor of network equipment going off and defining their own syntax and structure and way of defining their API, Yang provides a common modeling language through which to define that state. That state that I mentioned is hosted on the server and that the client can interact with. Thanks to Yang, we have a single modeling language for defining that and expressing it. And the really nice thing is whether you're using a network device from my company, from Cisco, or some other vendor, if they're using Yang, which they basically all do to describe it, it's going to be using the exact same syntax. So you don't need to learn the peculiarities of each vendor's modeling language. Show you what a Yang model looks like. This is IETF interfaces.yang. Now, not only is this using Yang, but it's also a Yang model that's defined by the IETF. So it's a standard model, which is even better now because now you have one way of defining what a network interface is. So this is really great because now when you want to interact with a network interface, it's going to be defined exactly the same way on all vendors' equipment. So here's an example of where standards really help us out quite a bit. The format of a Yang file, you can see it's just a text file. Basically, there's a container, which is the top-level resource that contains all the interfaces. Inside that container is a list of interfaces. Each interface has a unique name, a key, a description, and some other fields. Now, there's a tool called pyang, and what pyang will do is if you give pyang that IETF interfaces.yang file, it will output a tree structure that was represented in that Yang, or that was defined in that Yang file. The nice thing about this tree structure is, if you remember when we had to build out our request URI for the deck of cards API, this tree is exactly what you'll be traversing to build out your network device API. So let me show you how that works. Using this exact same IETF interfaces.yang file, oh, I forgot to mention, we're going to use a protocol called RESTConf, which is basically a RESTful API for interacting with network devices where the data is defined using Yang models. So you'll see this will look exactly like the REST request we saw before. You basically have an HTTP verb, in this case get, and we need to build out our request URI. And how we build our request URI out is defined by the Yang file that we just looked at. On the left-hand side is the pyang output, the tree, right, of the IETF interfaces file. What I'm going to do now is traverse that file down the tree so I can build out a request URI to request information about a specific interface, in this case, Gigabit Ethernet 1. The way I build this out is, remember, first I need to specify the protocol, HTTP or HTTPS. So in this case, it's HTTPS. I need to specify the server that I'm talking to. That's done using variables, so I have a host name and a port, and you'll see how these come in later. Then the resource that I want. I'm interacting with the RESTconf API and the data elements, and that's defined in the RESTconf RFC. That's where that comes from. I'm using the IETF interfaces Yang model. I want to request the interface state, and you can see how I'm traversing the tree on the left-hand side to pick up these elements. I want to ask for a specific interface, and the interface that I want has the unique name or key, Gigabit Ethernet number 1. So if I send my HTTP request, what I get back is this JSON formatted information describing my interface. And it's not just any information. It is very well formatted as specified in the Yang model. You can see the information that I get back on the right-hand side aligns exactly with the information that's specified in the Yang model on the left-hand side. So this way you have a very well-understood, well-defined way for accessing information, for retrieving information, and analyzing that information that you can write in a programming language. And I'll show you how you can do that using a couple things. One is, if I go back to this example, remember the host and port? Because I didn't tell you what the server was that was hosting this. So what I'm going to use as the server hosting this is this always-on Sandbox, which you can see the server name there, iosxemanagement.cisco.com. The port is, the RESTconf port for that is 9443. And unlike the Deck of Cards API, you actually need to provide credentials for this one. So the username and password are supplied there as well. Now I'm going to go and use Postman, which we saw earlier, to make a request using what we've just learned to this always-on Sandbox. So I build out the request. You can see the get. This is the exact same URI that we built out before, requesting Gigabit Ethernet number 1. There is, if you look at the top right-hand side, there are these things called environments in Postman. And in the environment, I can specify like the host name of my server, the port, the username, and the password. These are the exact same elements that we picked up from the Sandbox description. So I put that in my environment, and now Postman can use those, and it's the request that it builds out. I hit the send button, and what you can see is the response I get back. It's a 200 response, and the information that comes back is this exact same data that we saw formatted in JSON that describes my interface. So pretty cool. I can interact with that always-on Sandbox. But what's even better is, as we saw with the Deck of Cards API, if I click on the code button, I can similarly see what the Python code would be that I would need to write to make this exact same request. So I copy that like I did before. I put it into a file called getinterface.py. I just show you what that file looks like. I just copied and pasted it. And now if I execute that using the Python interpreter, I get back that exact same information that we saw in Python. So you can see here, without really knowing anything about Python or how to code, I could use Postman to build up my request. I could get code snippets of what that request looks like, and I can start to write a Python code, Python script that interacts with my always-on Sandbox. So far, everything I've showed you has to do with reading resources. Of course, with network programmability, you need to be able to create and modify resources too. So with the time that's left, I just wanted to show some examples of that. In this case, I'll be using an HTTP post. And if you remember from the previous one of the earlier slides, post is what you use to create a new interface. In this case, I'm creating a new loopback interface. And you can see it's loopback interface 42 in this case. So my post says I want to interact with the interfaces container, and I want to create a new interface, and you can see the definition of my new interface. And I didn't just make this definition up. The format of this, all the fields I needed to specify were based on what was in the Yang model, right? So I'm just filling in the fields that the Yang model asked for. If I go ahead and send that, I get back a 201 created, which lets me know, hey, it's successful. My new interface got created. Now let's say I want to go and verify that. So now I'm going to do another GET request, and this time I'm going to ask for my newly created loopback interface 42. I hit send, I get back a 200 response, and here I can see that the response coming back is the information I had requested for this interface, right? So it actually did get created. So that's great. Now, what if I want to get rid of that interface? Well, it's as simple as changing the HTTP verb in Postman to delete. And again, I give it the URL for the loopback interface. I hit send. And this time I get back a 204, no content. So 204 is another successful response. So my request was successful. But there's no data coming back because I asked to delete a resource. So if, the API can't really, there's nothing for it to send back to me. If I want to verify that it's really gone, I can make that exact same GET request that I did before for loopback interface 42. And this time I get back a 404, which you've probably gotten when you asked for a web page before and it didn't exist, verifying that interface doesn't exist anymore. So what I'm walking through here, you can see I actually have on the left-hand side, this is all part of a Postman collection that I built up to interact with this always-on sandbox. And if I wanted to build a Python script instead, I would start to cut and paste bits and pieces from each of these requests, and I could basically build up my Python script. Just that easy. Okay, so now the fun part, because I know I walked through a lot, and some of the slides were pretty small font. So if you want to try this out for yourself, I welcome you to do that. All the resources I've been using are free and available. The always-on sandbox, it's hosted in DevNet. It's free, but you will need an account to use it. If you're interested in creating an account, you can scan this QR code on the right-hand side, or you can type in the URL that was specifically generated for this event, ending in IIT RTC 19, and that'll take you to this login screen. And in this login screen, you can create a new account if you don't have a login ID. If you have a GitHub ID, you can just use social login that way. You can use Google, Facebook. If you have a Cisco ID, you can use that. So whichever way works for you, that just makes creating your account very, very straightforward. Once you do that, you'll have access to not only the always-on sandbox that I showed you, but also some learning resources, so you can walk through in more detail everything I showed you today. Here's a learning module that covers everything about REST APIs, or at least an introduction to REST APIs. Here's one on programming fundamentals, if you wanted to learn how to use Python and using JSON formatted data structures, for example. So some good information about that. And then if you want to learn more about model-driven telephony, programmability, this is using Yang models to interact with network devices. And you can see the bottom one there is using RESTconf. So if you want to get some experience with that. When you go to these, what it'll do is it'll ask you if you want to use your own computer, then you can do some additional setup. And the setup, it works on Windows, a Mac, which I'm using, or a Linux machine, if that's what you want to use instead. So hopefully, seeing the presentation and going through some of those resources, I've convinced you in less than 30 minutes that network programmability really can be as easy as flipping a switch. And I invite you to give it a try. I'm happy to answer any questions, and I'll be around the rest of the day to answer questions as well.
Thanks, Charles. We have time for a couple of questions. If anyone has questions on the topic Charles just presented, yeah.
Right, thank you.
Yeah.
Is this already deployed on all the iOS XEs, or is it only for specific product lines?
No, it's on all of them, iOS, XE, XR, and XOS.
Okay.
Yep.
Is it correct to think this one is like a next iteration of SNMP, because SNMP and there is a MIP, right? And then this gives you like a REST interface for the tree and traversing the values and stuff like that. Is it?
At a very basic level, yes. And if all I did was get requests, I think it'd be very similar to SNMP. Probably, I would imagine you use SNMP probably for monitoring.
Correct,
You probably don't use it for configuration.
No, right.
I mean, the whole reason network programmability came about was really because SNMP, it's not that it's bad, it's just not sufficient, right? It's not good for it's not good for configuration. So really the main value of this is being able to configure devices. Of course, you can monitor devices also. And one of the things I wanted to point out, which I didn't have time to cover in this one, but netconf is another standard protocol for interacting with network devices. RESTconf is probably the easier one. It's REST-like. Netconf is much more powerful and really good for if, for example, what you want to do is configure a new service, and you need to talk to a bunch of different network elements, and you need to configure them all at the same time, and you want that new configuration to take effect only if it succeeds on all of them, and if it doesn't, to roll back. That's very hard to do with RESTconf. It's impossible to do with SNMP. With netconf, it's actually relatively straightforward. I just didn't have enough time to cover netconf in this.
And another question is this only for configuring the ports, or is it I can model the service, like an MPLS end-to-end? Is it?
You can use it for everything. Okay. The one caveat to that is I chose IETF interfaces as my example. And that is one very basic model that has been standardized and is supported on everyone's network platforms. When you get up to higher level network services,
right.
There aren't not everything's been standardized yet. So what you'll probably find is that to configure that, you'd end up using some Cisco specific. They're still defined as Yang models, but it's not an IETF standard Yang model. It's a Yang model that Cisco defined. And if you were going to be using, Juniper device, it's probably something they defined.
Okay.
So that's the one caveat. But over time, the idea is, we'll standardize those as well.
Very good. Thank you.
Mm-hmm.
Okay, thank you. If there are additional questions, Charles will be around. You can catch him at the break. I'm sure we'll be happy to answer your question. So a round of applause for our first speaker.
Thank you.
Thank you very much.